So welcome to testing with JUnit 5 and Spring. Disclaimer, don't have to read that right now. So my name is Sam Brannen, and I'm a staff software engineer at VMware, and I've been a Java developer for over 20 years, so quite some time. I've been a core committer for the Spring framework since 2007, and a core committer for JUnit 5 since October of 2015 when we kicked off the JUnit 5 project. So today we're going to talk about features in JUnit and Spring, and then have some time for Q&A at the end, or if there's not enough time afterwards, you can just find me out in the halls here. So first up, I'd like to point out that JUnit Jupiter and Spring are a great match for testing, for integration testing. So in the core Spring framework, you have the Spring extension, which you can register with @extend with in JUnit Jupiter. We also have some convenience annotations, Spring JUnit config and Spring JUnit web config for web application context. And in Spring Boot, you're hopefully familiar with the @Spring Boot test annotation, which is also meta annotated with that extend with Spring extension, getting Spring support in there for you by default, and then also various support for so-called slices, testing slices at WebMVC test, etc. in Spring Boot. So JUnit 5.8 has been out since late last year. Some of the major features in the platform, so focus on the platform first and then on Jupiter on the programming model. One big new feature is support for what we call declarative test suites with a new @suite annotation. There's a new suite test engine in the JUnit Platform suite engine module that you can include in your build, and there are new annotations in the API for that as well. So there's this new @suite annotation, but there's also some other ones like @configuration parameter, select URI, select file, etc. Another thing we have there is the unique ID tracking listener. This is a test execution listener from the JUnit Platform API, not the Spring testing API. And that just tracks all the IDs of the tests that were run, generates a file containing those, and then you can rerun those afterwards. For example, this is used within the GraalVM native build tools for selecting which tests to run within a native image. So if anyone had seen this before, this JUnit Platform class, we have @runwith JUnit Platform. That was using JUnit 4 to launch JUnit 5, and we originally introduced that before there was support in IDEs and build tools in order to be able to run JUnit 5 test engines using the JUnit 4 infrastructure. So you could have done this like this in the past, supplying display name, selecting packages to scan, etc. And that's the old way to do it. Again, that's using JUnit 4 to run JUnit 5, and we really don't want to be doing that. And that's why we have the new suite engine. So you can just replace that, and now you can have JUnit 5 running JUnit 5, and this will run all the test engines that you configure, or you can select particular ones. Like here we have only JUnit Jupiter that we want to include in this. And we actually switched to this in the build for the core Spring framework. Another thing I'm not mentioning here today is there's also support from the JUnit team for running test and G tests on the JUnit 5 platform. So there's an engine for that, and we actually make use of that in the Spring core build suite. So we have a suite, and we run with the test and G engine, and we could include those in our normal JUnit 5 build. Now some small enhancements. If you want to know more details, you can always check out the release notes. Here's a link to the 5.8.0 GA release notes. One thing we added is more fine-grained support for Java Flight Recorder, JFR events, and adding support for Java 8 if you're on update 262 or higher. In the assertions, we have assert throws exactly as an alternative to assert throws, assert instance of, instead of writing assert true and then checking or providing your own instance of check. And one minor detail, @register extension fields are now allowed to be private. So now for the major features in JUnit Jupiter, so the programming model. This is often what people refer to as writing tests in JUnit 5. We have new test class execution order support. There's a new class order API, which is analogous to the method order one that we already had for several generations of the framework. And we have some built-in implementations. We have support for ordering the tests based on their class name, which is actually the fully qualified class name with the package included, based on the display name, custom display names, based on the @order annotation, or sorted randomly if you want to make sure things are working and not depending on any particular order. And you can, of course, write your own. Someone out there, after we release it, wrote something for his own project using Spring Boot and basically organizing his tests depending on whether or not they were annotated with that Spring Boot test or MockMvc test, so kind of running the slices in a different order, or the Spring Boot integration tests or the standard JUnit tests. So you can basically sort them any way you want, and basically it's up to you how you want to do that. Now if you want to configure this, it doesn't make any sense to do this on a class level for normal test classes. So there's a configuration parameter called JUnit Jupiter test class order default, where you can set the fully qualified class name for your orderer. For example, if you wanted to optimize the build, if you wanted to somehow track which tests were taking longer and maybe run the faster, slower ones first or the faster ones first, whatever, it's up to you. Now, one thing you can do though, if you have nested test classes, you can configure those locally with an @test class order annotation for nested test classes. So here we have an example. We have ordered nested tests. We have 2 nested test classes in there, annotated with that nested, and we're setting the class order to be the order annotation implementation, and we're specifying we want this group of nested tests to always run before these. So you might have some use cases for that when you have nested tests. Tempter, you've probably seen this. You know it from JUnit 4. You may have already used it in JUnit Jupiter. We have new behavior in 5.8 due to popular demand from the community. There's a lot of discussion about that, how it should work. In the past, what happened is whenever you declared @tempter, you got a single temporary directory per context that was shared. But now you can use it to create multiple temporary directories. So basically, anytime you declare one of these @tempter annotations, you're going to get a new tempter that you can use in your tests. But if you like the old behavior, or if you're still depending on it and want to migrate to the new behavior, you can set a configuration parameter called JUnit Jupiter tempter scope, and you can set that to per context, and it'll work like it did before. So this is more of an improvement for the programming model in general, maybe for yourself if you're writing your own extensions, or for third parties who are providing extensions for you. @extend_with can now be declared on fields and on parameters. So previously we had @register extension. You could use that to register extensions programmatically, kind of like the rule support in JUnit 4. That's nothing new, and the new part is that extend_with can also now be used to register extensions on fields and parameters, but this is a declarative approach, just like you would do at the class level or the test method level. For fields, they can be both static or instant, and they get different scope. And for parameters, that can be applied to constructor parameters for your test class, lifecycle methods like @beforeAll, @beforeEach, test methods, etc. Now typically this would be used as a meta annotation, so an annotation on top of another annotation, and that basically avoids the need to have to declare @extend_with the class or method level. And we'll see that in an example. So let's imagine we had a random number extension implementing a couple of APIs from JUnit Jupiter that's supposed to inject a random number into your tests, and you didn't want the user to have to know about the register or about this extension registered on their own. So you could come up with your own public annotation here. @random, it is meta annotated with @extend_with random number extension, and this is package private, so it's not even visible to the user. Basically the API or the program model for the user is basically just use @random and you'll get a random number. And that could be used, for example, like this, on a field, in the constructor for the test, in lifecycle methods, and the test methods themselves. So again, this is basically just making it a nicer programming model if someone wants to provide a random number injector. Named API is something new. Basically, this is just a container that associates a given name with a given payload, and the meaning of the payload depends on the context in which it's used. There are 2 ways to get one of those or create one of those. You can use the named of static factory method or named, where the latter is intended to be used with a static import just for better readability. 2 use cases we support out of the box. In dynamic tests, if using the stream method, that can now consume named input, where each of the name value pairs is going to be used as the display name and the value for each generated dynamic test. The other use case is in parameterized tests, if you're using method source or argument source. The arguments that you can return from those can now have explicit names associated with them supplied via the named API. So people have asked in the past, how can I programmatically kind of specify the name for some of my arguments? So again, with method source or custom argument source, you could use this new named API. And that's actually quite powerful. I've used it a lot in my own tests, and you might want to check that out if you ever have a name and you're wondering, can I change this? Can I make it something custom? This is one way to do it. Here we have an example with the dynamic tests. So we have a test factory method returning a stream of dynamic tests. We're setting up our input stream, which is a stream of named things. Here the payload is the type, so the string. And for each of these, we're just importing that static factory method here. And we're specifying the names on the left as the first parameter, and the payload is on the right. In this case, it happens to be a string as well. And then we're just returning a dynamic test with this stream method, passing in this input stream that has named content in it, and then specifying our dynamic tests where each thing passed in is the string. So we're just checking that each one of those is a palindrome. So that can be very useful as well in dynamic tests. Another feature we have for parameterized tests in JUnit Jupiter 5.8 is support for auto-closable arguments. So in the past, if you had something that you created with some kind of resources, you would have to close them on your own, find some way to do that, maybe with a custom extension or something like that. But now in parameterized tests, the arguments, any argument that implements auto-closable will now be automatically closed after the test completes. And if you don't want that in the parameterized test annotation, there's a flag where you can turn that off. I believe it's auto-close arguments equals false. So this allows you to clean up stuff automatically after parameterized tests, maybe closing a file, stopping a server, etc. This is similar to the closable resource interface we have. You might be familiar with if you've written your own extension. So in the extension context store, there is this closable resource concept, but we just decided to go with the standard Java auto-closable interface for arguments that you provide to a parameterized test. Some small enhancements that came in after the 5.8 GA release, 5.8.1 and 5.8.2. You can check out the release notes for more details. Basically what we did is we added support for text blocks in CSV source files. So JUnit 5 is based on Java 8, but you can of course use later versions of the JDK. So you can use text blocks if that's available to you. We also added support for using CSV headers in the display names if you're using @CSV source or @CSV file source. And we allow support now for custom quote characters as well. We added support for Java 18 in the JRE enum, in case you want to use that for things like @enabled on JRE, @disabled on JRE, etc. And if you're writing your own extensions, in the extension context, you can now get access to the execution mode to determine how things are running in terms of parallel test execution and then react to that. So here's an example of @CSV source. You might have seen these before. So we have a parameterized test, CSV source, where each one is a string. So this is an array of strings, it's accepting here as the attribute. And that works fine. Each one of these gets passed in. So fruit and rank, those get parsed and passed in here. But now with text blocks, you can make it a little nicer. It's like writing your own CSV file in line in your code, right? So here we have text blocks equals and start the triple quotes there. One thing you want to do is make sure these line up, right? Because now you can also have comments. If the first character is a hashtag, then that will be ignored as a line, as a comment line. But if these things don't line up, then that might not be the first character, so be wary of that. And you see now we can also change the quote character to quotes, if that makes more sense for our use case. Previously we had single quotes around lemon lime, and now we have double quotes, right? Because we can have double quotes inside of a text block in Java. And the other feature there is using the CSV headers. So on the previous one, that was a comment. Now this is an actual line, and we want that to be interpreted as the names that we're passing into our parameterized test. So we say use headers and display name is true. And now instead of using fruit and rank as the names in the display names for parameterized tests, it will actually use fruit and rank here, or whatever else happens to be there, as the headers for each of the columns in the CSV file there. So basically, with CSV source, with text blocks, things are now more powerful. You can change the delimiters, change the quote characters, have nested quotes and all sorts of stuff like that using headers. Basically makes it a lot nicer. In the past, you might have used CSV file source and written stuff to a file. If you're only using it in one place, it now might make more sense to just inline that into your Java code. So you basically see the contents of the file right above the test method. So that's it for JUnit 5.8. We'll talk now a bit about JUnit 5.9. We just released that last week. So in JUnit Platform 1.9, right, milestone 1. You have the release notes linked as well. We have support for the new open test reporting format for XML reports. So you might be familiar with what they call the de facto JUnit 4 XML report format that's been used in Ant and Maven and all over the place for years, but it has some limitations. For example, it doesn't work nicely with the JUnit platform in terms of the hierarchy you can have with various levels of nesting between containers and tests and dynamic tests, custom display names and stuff like that. And so we've talked about it for a long time, and the lead for JUnit, Mark Phillip, put in a lot of effort into this and released the first version here of the open test reporting format. We encourage people to check it out, and we're going to be talking to build tools and IDEs to see if they might want to support that as well. And we hope that this will eventually replace the de facto JUnit 4 XML format. Of course, that will probably take, who knows, 3 years, 5 years, 10 years to happen. Maybe tools will support them both in parallel, and we invite you to check it out and see if you find any shortcomings in it, or let us know if you like it, etc. So basically, this is an optional feature now. You can turn on the listener that will generate that report for you, and you might start processing that XML on your own, or you can even have it generate JSON and other things like that, or convert it to JSON. So here's a link. OTA for JTeam, that's the Open Test Alliance for Java, and that's the project there, Open Test Reporting. Another thing on the platform, there's a new iteration selector. If you're launching the platform using the launcher APIs, if you've done that kind of thing in your own custom test run setup, and you can use that for selecting a subset of a tests or containers iteration. So for example, in JUnit Jupiter, that would be used for selecting a subset of dynamic tests or parameterized tests. In terms of the console launcher, so that's how you can run the JUnit platform from the console. We have a few improvements there. We have support for the color themes that are used. You can use single color to make it monochrome if you have visual concerns, and you can also set your own custom color palette to change it. So previously we had a hard-coded color palette, but now I can provide a properties file and specify the colors that will be used with the console launcher. Another feature is the ability to list all of the engines that are registered in your current class path or module path, if you just wanted to see those and query what are the available engines. And another feature we've added there, I mentioned we have the new suite engine added in 5.8, and now it's also included by default in the standalone jar for the console launcher, so that you can run test suites from the command line automatically with the standalone jar. JUnit Jupiter, we also have some new features just released. One thing for Tempter, we have support for a new cleanup mode. So in the past, it would always just delete the Tempter automatically. And then if your test failed, you're left wondering, what did the file system look like, right? What did those files look like? So someone said, can you please provide a way to leave them around? And now we have options. So always is the default, so it's just going to delete them all. But you can change that to on success, so only if the test passes should they be cleaned up, because you don't want to look at them because everything worked. Or you could say never, you always want to inspect them. So this is a nice feature. What I foresee people doing is probably just turning this on when a test is failing, right? So you run the test, it's failing, you're working on it, going back and forth between fixing your production code and running the test, and you want to see what happened in the file system, change it to never, and then analyze it. Once you get the test working, maybe switch it back to the default and let it clean up afterwards. Or if you don't want that, you can set a configuration parameter to always set the default to never, for example, for your build. Another thing we have for people writing extensions, we have a new test instance pre-construct callback. It's kind of a mouthful to say, and that's a counterpart to the existing test instance pre-destroy callback. So basically, if you had an extension that needed to do something, set something up before the test class is actually instantiated, there's now a callback for that. Next up is, might not sound too exciting until you maybe see what it can do for you. We now have support for reusing the parameter resolution mechanism, and that's now made available to extensions. So that's via the extension context. If you're writing an extension, you can now invoke on the extension context get executable invoker, and then invoke a constructor or a method, and it will invoke it with the same power that we have for the parameter resolvers. Like you can get things from Spring, right? You can get a bean, for example, and things like that. And I have this question mark here. Haven't implemented it yet, but this is something I could potentially implement in the framework. So we have at before transaction and after transaction annotations in Spring's testing support when you're writing transactional tests, but they cannot accept any arguments currently. Whereas a before each method, which is invoked by JUnit, can accept arguments. So we could access a data source or a transaction manager or your repository, something like that. And with this new feature, Spring could now actually update the code there and invoke these methods also with parameterized resolution coming from JUnit Jupiter. So maybe access to the test info to get access to the current test method, or maybe accessing a bean from the application context, and I'll show you an example. Another thing is method source is actually building on this new feature, because once we implemented the one, we realized we could do it for method source factory method. So if you have a parameterized test with that method source, previously those also could not accept any arguments. But now with this new feature they can, and they will be resolved by the standard mechanism for parameter resolver extensions. So now I will attempt to do some live coding for this. Let's see how this goes. So I have, it's gonna, that might be kind of small, huh? Let's see what happens. If I make a new class, method source, tests, there, looking good so far. And if we wanted to make it Spring JUnit config, sounds good. That's going to need a configuration class. Oops, configuration class. I'll call it config because that works for me. So at this point, we have hopefully Spring running with JUnit Jupiter. We're going to need a test method. Let's pick the right one. Jupyter API test would test, and that should run at this point. Oh, that's not what we want to do. Let me put it in here. This happens to be a modular project. Let's ignore that for now. All right, so the test runs, and we're saying we wanted to make this a parameterized test. Parameterized test, and we want to have method source, right? And we're going to need some kind of method. We're going to call it Spring strings, something like that. So it's expecting a method here. By default, it has to be static. So, oops. Static. What's it going to return? Maybe a list of string. For example, it could be a stream or something like that. And this is supposed to return something, so empty list. Let's just see if this thing runs now. If I tell it I want to have a list of, or each one should be invoked with a string, right? Does that make sense? So we have a parameterized test. It's going to invoke this method that's going to return a list of strings. This will be invoked each time with that. And now there's nothing in there. Let's just put Spring IO. Now we should see in the results, hopefully there's a Spring IO is invoked. Now what if, for some crazy reason, we had strings as beans? I only do that, not that you should, but just because it's easy to demo. Alright, so now we got a configuration class that has a bean called foo. This thing, we want to access the beans. What was I saying we can do now? I was saying we can access beans. Oops, it's a little difficult to type with my palm hitting the trackpad. Sorry about that. Alright, so now, instead of creating something custom, we're pulling that from the application context. So it's going to launch JUnit Jupiter. It's going to launch our Spring application context with the foo bean in it. It's going to use the method source, this method, and this thing can now accept arguments, right? And they can be beans for your application context. So what happens if I run it again? Any ideas? Does it say Spring IO anymore? No, it says foo, right? And we could have a couple of different ones. Bar. And if I run it again, well, if I could get it to compile. All right, now we see the tests that were run are in fact foo and bar. Now again, this is just an example. Hopefully you're not doing a whole bunch of string beans in your application context. Maybe you have different kinds of implementations of a strategy, or maybe you're not doing this, this collection auto-wiring trick. Maybe you're getting hold of an order repository and interacting with your database and building up the parameterized test method based on real data from your database or something from the file system. And basically the sky is the limit. It's up to you. My main point was to show there's a new feature in JUnit Jupiter where a method source can now accept arguments, and with Spring you can auto-wire anything in from the Spring application context. So I'd like to see what people come up with. I think it's probably a pretty nice combination between JUnit Jupiter and Spring. Any questions on that? All right. So Spring Framework 5.3, I'm actually talking about 5.3.x because not all of these features were implemented in 5.3 GA. We have actually introduced testing features over the course of the 5.3.x timeline. If you want details, you can check out the release notes. There's multiple of those. We're up to 5.3.20 now, is that right? So one main feature is that test configuration is now discovered on enclosing classes for nested test classes. If you'd ever used nested test classes with Spring, you might have thought, wow, this is really painful in the past, and I'll show you an example how it used to be and how much better it is now. Another feature we added is application events. I don't know if Oliver Thropboom is here, but he's at the conference. This is something he pushed for. So basically we have a new abstraction in the testing support for capturing all the application events that were fired while your test is running, and you can access those and base assertions on that. The other feature we have is we already had support for test constructor auto-wiring configuration, setting the auto-wire mode. You could configure that as a system property before, or in the Spring properties file. You can now configure that in the JUnit Platform properties file as well, in case you're already using the JUnit Platform properties to configure other things in JUnit Jupiter. Now you only have one file to configure for these testing features. Another thing we added was prior to this, you might have thought, oh, I'll put add auto-wired on a test method or on a before each method or something like that. And what would happen is that Spring would see that and think, oh, this is a configuration method, and it would invoke it to auto-wire it. But then JUnit would come along and say, oh, it's a test method, and it would invoke it again. So that's something you don't want to do, right? Because then your test method gets run twice, or your before each method gets run twice, etc. So now we have built-in detection. If you do that, if you make that mistake, the Spring extension will now throw an exception telling you, please don't do that. We have some various improvements for MockMvc support and the Mock REST service server, and also various enhancements for our mocks for the servlet API for requests and responses. We have support for, or improved support for parsing SQL scripts with regard to the delimiters and comments and nested comments and nested delimiters and stuff like that. Basically, it can parse more than it could before. In the testing framework itself, there's a new class called Exception Collector. If you want to write your own kind of soft assertions, which I'll talk about in a second, you could use this. I just want to point that out in case anyone has some advanced use cases there. Speaking of which, yes, we do now have support for soft assertions for both MockMvc and the web test client. So if you've used TestNG or AssertJ, right? AssertJ has soft assertions. You can say assert slothfully, and then it'll collect all the exceptions and throw them all together, all the assertions, right? All the failures, instead of failing on the first one, right? So that's what we have support for now. If you're using HTML unit with MockMvc and you're creating in-memory files instead of reading them from the file system or something like that, we now have support for the set data method that now works correctly with MockMvc. For the servlet response, you can set a default character encoding, and you can also set the default default character encoding for responses with MockMvc. So this is just kind of a tip I throw in there. This is a general tip. Use text blocks where you can. If you are on a high enough version of the JDK, you can use it in your production code, but it turns out it works really nicely with test code, right? Like if you have something where you're trying to create a small little XML file or small little JSON document, it's much nicer to do it with the text block. The same is true with CSV files, as we just saw. And my tip is, use it where you can. Try stuff out. So for example, add SQL, you might be familiar with that in the Spring Test Context Framework. So support for executing SQL statements that are inlined. You can also access them from files, but you can have them inline. Now, originally designed, I designed this, it takes an array of strings, right? So each one is supposed to be a separate statement. But it turns out, because of the way that I wrote it, if you do a text box there, it just works. So that's because it's going to execute all of them at one time. It's going to parse them all and execute them individually, sorry. So basically, try stuff out, see if it works. At SQL, that works nicely. If you tried something like test property source, that won't work because I built in code there that verifies that it's only one statement or one property that you're setting there. So again, just try stuff out, see if it works. Maybe in other places it's Spring as well, or maybe in other frameworks that you're using. Just give it a try, see how it works. Now this nested testing support, as I mentioned, basically from Spring Framework 5.0 through 5.2, if you had nested test classes and you're using Spring testing support with an application context being loaded for you, here we have an example, Spring JUnit config, loading the test config, setting the active profiles to dev, making it transactional. If your nested test class was based on the same assumptions, you had to copy every single annotation, and the same with Spring Boot annotations. And that's painful, right? So I made it better. But here we have an example where this one's using a different one and didn't want that. And if you wanted that same kind of configuration to work after migrating to 5.3, we'll see by default, everything is inherited from the enclosing class, right? This is not the super class because it doesn't extend that. It's just nested inside there, right? But now we look on the enclosing class to find the configuration. There's also support built in Spring Boot test, Spring Security testing, and other parts of the portfolio. If you find a scenario that doesn't work, please let the respective portfolio project know that the enclosing configuration is not being found. But we have a new annotation, nested test configuration, and you can change it from inherit to override. So again, this one wants to have its own configuration, doesn't want to use these profiles or be transactional. You can actually override and not inherit from the enclosing class. So that's a big benefit if you are using nested tests with Spring, Spring Boot, etc. Here's an example with the application events. This is an opt-in feature. There is a test execution listener that's registered by default, but it won't do anything unless you annotate your class with record application events. So that will turn on this feature. Then you can access the application events. Again, I mentioned that was a concept we have here in abstraction. You can just auto-wire that in. Then in a test method, for example, if you know that your order service, when you submit an order, it's supposed to publish an event, right? So this thing is tracking them for you. You can then assert that that event was fired and even test things on the event. So here we have events stream. You can stream them by a certain type. We're saying this thing should have published an order submitted event, and you can just make sure there's one, or you could actually inspect that and see what's in the event. So that would have been rather challenging to do on your own previously, and now that's a built-in feature with application events abstraction. Now we're going to talk about these soft assertions. If you haven't seen these before, this should make it more concrete. So in the past, you might have had something like this: perform a GET request to person/5, expecting JSON as a response. The status should be OK, should be a 200 HTTP response, and in the JSON response, the name will be Jane. For that, person5 should be Jane. But what happens here? What if this doesn't work? If this is not an OK, an exception will be thrown there. You run the test, it fails there. You try to fix that, you run it again, and then it's actually John. You didn't, oops, Jane. So, or maybe the name is spelled differently or something like that. So then you have to run the test multiple times to find all the failures. What if you want to find all the failures at once? But what if that helps you deduce the problem and fix the problem faster? So that's why we have soft assertions. Now you can say and expect all, and then just supply, this is a var args here, list, comma separated, status is OK, JSON path, name is Jane. And if both those fail, you'll get failures for both of them, right? Similarly, with the web test client, the API is slightly different because it's a Fluent API. We have exchange, expect status is OK, and then this is a dot continuation of that invocation, right? Fluent API, expect body string is equal to hello. So similarly, if this one fails, it doesn't check the hello. But maybe you want to check both at the same time. And the way you do that with the web test client is you use this new @expectAll method here. Now, since this is a Fluent API, it's not going to look the same as here, which is a comma separated list. We're going to have to access this spec. So we're actually writing consumers, right? So these are little lambda expressions where each one is taking the spec and checking the status on it. The next one takes the spec and it checks the body. But then each one of these lines, each one of these consumers will be invoked. The exception will be caught, and they'll all be tracked together, and it will throw a new assertion error with all of these exceptions as, well, there's a summary in the assertion error message, and there's each one of these is a suppressed exception. So you can actually look in the stack trace and see each individual assertion that failed. I mentioned we have better support for in character coding in general in MockMvc. So here we're setting the default response character encoding as we set up the MockMvc instance that we're going to be using in our tests. And here we just have an example that if that were the case, that was set as a default, if we pass in character coding UTF-8 going in, then on the way back out, we expect the response to be UTF-8. So this was written for a test case that would have failed without this line in bold previously. And now you can set this. The reason you want to do that is that, for example, if you're setting up your Tomcat server container, another server container, that's an option you have in the server container. You can set up the default response character encoding. And if your application depends on that being like that in production, you can now make sure that your tests have the same configuration by setting the default response character encoding. So, Spring Framework 6, testing enhancements. There's not much to talk about, but I'll say a few things. First thing is actually quite important. It's a big change. We just added this in last week. I just pushed the changes for this. We now have support for scanning the module path. As you know, we've had support for scanning the class path. And basically on Java 9 and higher, most of the time the class path scanning just works fine for you, but there are use cases where it might not work. One that has surfaced and has been a pain to some people has been when using Maven Surefire in a Maven build, and the default configuration there is that Maven will patch your test resources and test classes onto your application module, and then the class path scanning in Spring doesn't work. So you're having an example application. I'm going to show you in a minute, and this is basically, I'm going to probably add some more things here. We're focusing a bit more on providing examples for how to work with the module system in Spring 6 and above, making sure that it's okay or that it's possible to test. And this was the first fix, the first change to the code base. Again, this is not specific to testing support. This is actually in the core support for basically support for anything looking up a class path star :resource. If you're familiar with that, that's the functionality behind the annotation at component scan in core Spring and component scanning in Spring Boot. So that will now automatically scan the module path in addition to the class path. Again, not specific to testing, but can certainly surface if you're using Maven Surefire and patched modules. Another thing that this is not yet implemented, but one thing that we're intending to implement is providing support for or a mechanism for avoiding repeated attempts to load an application context that fails to load in your tests. So if you have the same configuration for an application context that's supposed to be used in like 50 tests across different classes, and it's just broken and you're running your test suite, it's going to fail 50 times. And if each one of those takes 10 seconds to fail, well, you're going to be waiting that long for all those failures. And people complained about it over the years, and I would like to make a change to that in 6. So basically just provide a way to check whether a particular application context has failed, maybe how many times, maybe set a max number of retries for that before just failing automatically. So hopefully we'll get that in before 6.0 GA. If not, there's 6.0.1 after that, right? Yep. Another thing, I mentioned this before, right? So we could now, because of this new feature in JUnit Jupiter 5.9, at before transaction and at after transaction methods could now accept arguments, just like we saw with that at method source example a few minutes ago. So otherwise, there's not much else currently planned for 6.0 GA in terms of enhanced testing support in Spring. That might change. We'll see, but we're focusing on other things as you've seen throughout the conference right now for 6.0 GA, and that leaves us time for 6.0.x, right? So we can add more features in, basing on some of the new mainline or major features we're adding in 6.0 GA in general. So I do want to quickly show this this application. Let's get rid of that because that will actually fail my tests. Its mere presence will make it fail. Okay, so we have a very simple application. It's just going to load an application context, get the grading service, and run it. And what should that do? It's not going to be exciting. It's just going to print hello Java module system. But this is a modular project, right? It has module info, it's opening up ComExample for so that's ComExample module, and it's opening up the ComExample package for reflection, and it's using some of the core Spring libraries. So it has this application. What does it do? What does it actually load in? I didn't show over here. The config class, there it is. It's a configuration class. It component scans in the current package, ComExample, and everything below. What do we have in there? We have a greeting service in that package. It's annotated with that service. That should be found via component scanning, and that's the thing that we're invoking there that's printing that out. So about as simple as it gets for a Spring application. We saw the application run. Now what if we had a test for that? Spring JUnit config, specifying that configuration class, which again has the component scanning, right? It's supposed to find that greeting service. We're trying to auto-wire that in and then write a test that verifies what we saw on the command line there. Now, if we switch to, oops, last one wins. Hopefully is it going to rebuild there. Now if I go to this test, assuming this fails the way I expect it to, it failed. Why did it fail? What does it say? No qualifying bean of type greeting service. It could not find our greeting service. Well, that's very strange, right? Looks kind of strange. It's like, so okay, here's the app config that did a component scan. It's in the same package. It's right there. But again, in Maven Surefire, this is a patched module. And if you're scanning the class path, sometimes certain things aren't visible, and they're only visible if you use the module APIs and scan what's called the module path. So now if I switch back, if I use the snapshot, it's not released yet. This is going to be coming out in 6.0 M5, so the next milestone for Spring. Now if we run the test again, now it passes. So my point is, if you're working with the module system and things aren't being found with class path scanning or some kind of resources, that will be coming in 6.0. If you find other situations other than the patched module system, patched module that's not working for you, please let us know in the issue tracker. We encourage you to try out the 6.0 M5 milestones, or if you're writing applications with the module system, writing tests with the application with the module system. And if this fix doesn't fix your problem, please let us know about that as well, so that we have time to fix that before 6.0 GA. So now we have time for, I think we have about 8 minutes left, is that right? 7 minutes? So we have a little time for Q&A. No questions?
Hello.
Hello.
Thank you for the presentation. My question for you is about the reusage of the Spring context during the component tests or integration tests that we are running, or any test. Yeah, I know that for every test, Spring will create some sort of a hash. It will cache the test context. If it's similar to the next test that you are using, it will try to use.
Yeah. If it's the same, exactly the same, yes.
Yeah, and for instance, if in the next test you have like a MockMvc or a property source that you change it, it will spin up a new context, and it sometimes takes time. The question is there any way to make this a bit more dynamic, where the context can recognize that you just changed new stuff and just injecting the same application context to not spin up a new context?
Well,
every time?
Sorry to disappoint you, but the answer is no.
Okay.
Right, so when you have different configuration, Spring doesn't know the ramifications of what that might result in your bean, in the object graphs, and which things are depending on that. Spring doesn't do any kind of static analysis to say, oh, this bean used this one property and it's only affected, and it doesn't really change it, but it kind of changes it. So we really can't do that. And the other thing is that the application context, they can be used in parallel, right? You can have parallel test execution, and you don't want to change an application context while another one's running, because then the results are undefined, right? So then you'll have random failures. So it is a bit of a nuisance, right? That a small change can create an entire new application context. The best thing to do is to try to do your best to reduce that, either reduce the scope of that one test so it's not loading as much, or just reduce, limit the amount of usage where you're actually changing the beans, like with that mock bean or spy bean, or changing the properties. That's the best advice I can give.
All right.
Hello, nice talk.
Thank you.
Congratulations. In the last example, if you don't put the module info in Spring 5, it will work, no?
That's correct, yes.
Okay, so if you, for example, have a project in Spring 5 and you want, for example, to upgrade to 6, in theory, if you don't use the Java Platform module system, it will work everything, no?
Yes, that should be fine.
Because
Yeah, it's just an issue if you switch to the module system, and most cases that we've seen, the class path scanning will continue to work the way it worked
Continues to
before.
work,
This
no?
one particular
Because
situation that comes up that people have talked about a lot is, oh, I'm using Maven Surefire. Oh, and Maven Surefire creates a patch module. Oh, and the class path scanning from Spring doesn't work with the patch module because it only sees the test resources because of the way it's patched. It doesn't see the production
Okay.
resources. It can load the classes, but it can't see the class file. And that's why the class path scanning doesn't work.
Exactly. So you can switch without any problem, no?
Yeah,
To
yeah. If
6.
you're not using the module path, not deploying to the module path, don't have module info, right? Then it's the same class path scanning that's always been
Yeah,
there.
yeah, yeah. Okay. Thank you very much.
Sure.
Great talk, Sam. I just wanted to, I have no question. I wanted to, regarding the first question, I'm giving a talk at 5 exactly about reusing the application context. So
Okay.
want to do some dirty advertisement here. Room 6, I guess. So if you're interested in how to reuse the context, what to do, what not to do, check out my talk. Thanks.
Sounds good. Muy bien.
Yesterday there were a few presentations about GraalVM and executing native or compiling native code, let's say, and executing then it pretty fast. Any plans for executing unit tests like JUnit tests such in such kind of way? So compile them and execute them, let's say, in the cloud where you pay for time of execution. Will this be supported someday?
So this is not a Spring feature. This is I used to help with the GraalVM native build tools. I mentioned that at one point with that unique ID tracking listener that's used in there. So you can check out the GraalVM native build tools project, and you can already use that with native images, right? So it'll run, basically what it does is it'll run your tests on the JUnit platform, your JUnit tests. It'll use that listener. It writes them to a file, and then it's going to compile your tests into a native image. It's going to compile the JUnit console launcher in there as the main application to run, and it's going to read in that file of all the things that it ran on the JVM, and it's going to run them in the native test. So that support is already there from the native build tools project.
Thank you for the presentation and for
Sure.
your answer. Thanks.
You're welcome.
Hello.
Hello.
For recording application events, if we fire application events in different threads, would the test record all the published events?
It should, yes. As far as I know, it should, yeah.
Okay. I played around a little bit and it seemed like it's not registering if I fire in different threads, like a wrap up in some complete of a future or
We could
whatever.
we could look at it. If you find an issue it's not working, get in touch and we'll
Okay. Okay.
take a look. 1 minute. 1 minuto. Looks like there are no more questions. So thank you for coming.